Okay, so a problem statement titled AI ML based auto evaluation of R&D proposals received at NaCCER CMPDI Ranchi focuses on automating the evaluation process of research proposals submitted to Coal India Limited's R&D arm, NaCCER. So currently, every proposal undergoes manual scrutiny for technical feasibility, financial viability, and novelty, which is really time consuming, subjective, and prone to errors. With the growing number of submissions, this manual approach causes delays and inconsistencies, sometimes leading to the rejection of potentially valuable projects. So, our solution aims to build an AI ML driven system that automates this evaluation. It will benchmark new proposals against a centralized database of past and ongoing projects to assess novelty, perform automated financial compliance checks, and generate an objective evaluation score for each proposal. This system will standardize and speed up the review process, reduce human bias, and ensure transparency and efficiency in decision making for R&D funding at NaCCER.
So in our technical approach, I will be explaining you about the use of the central repository. Also, I will be explaining you how we were performing the novelty analysis using our RAG pipeline. Okay. So we are using two types of the databases. One is relational database, and for that we are using the MongoDB, and for vector database we are using ChromaDB. Okay. Now, first of all, we will be taking all the proposals. Okay, the proposals that are already approved or that are under reviewed or that are not approved. Okay, we will take all the proposals and saving those proposals metadata into the MongoDB. Okay, and also now we will be taking all these proposals at a time, and we will be dividing into the chunks, and we will be performing the LangChain indexing so that it can be converted into the vectorized form, and we will be storing into the ChromaDB. Now how we perform the novelty check. Okay, now we take the proposals, new proposal. Okay, we divide into the chunks, and we perform the LangChain indexing and the embedding formation. And okay, now we query the vector database so that we can find the most similar proposals. Okay, and now once we retrieve all the most similar proposals to that the proposal we are given. Okay, once we retrieve all the most similar proposals, now we re-rank these proposals again using the cross encoder so that we can get the most so to ensure that we can get the most relevant proposals for our novelty analysis. Okay.
On the continuation of what just Azam said, once we retrieve the most similar proposals from our vector database, we're going to perform a re-ranking on them using cross encoder. We're just making sure that we obtain the most relevant ones. So from these relevant re-rank proposals, we're going to take the top k most similar proposals so that these top k ones can act as the context for our LLM prompt. So this prompt basically contains we add the context, which basically contains the combination of our new proposal along with the top k ones. So we feed this prompt into our LLM we just showed here. So our LLM can perform novelty analysis on this new proposal. After this novelty analysis, we basically stored our new proposal into the vector database that contains all the historical proposals so that this new one become the part of our whole system so that we can use this further for our future novelty assessment. This one is basically the whole novelty assessment case. Now we're going to move into our S&T guidelines. One S&T guidelines is basically a rule book on which proposals are scored, they are evaluated, they are verified. It basically a number. It contains number of pages, contains complex rules. What we did on it, we basically perform indexing on these guidelines on all these number of pages, and we divide these whole guidelines into different chunks using a different lang chain and stored them into a different vector database. So when we are analyzing the original proposal that user gave as an input, we're gonna retrieve the most relevant chunk from this whole vector database. These chunks are basically the guidelines. So we re-rank these relevant chunks, these relevant guidelines, and we're gonna take the top k guidelines from all these re-ranked ones, and we're gonna send this as a context along with the original proposal that user gave as the input. So this whole will become a context, and we're gonna add this whole context in the prompt, and we're gonna feed this prompt into our LLM so that our LLM can perform S&T guidelines analysis on this new proposal and can generate the report based on these guidelines. So yeah, this whole comprises our whole novelty assessment case and our S&T guidelines case.
We perform re-ranking because initial retrieval methods like vector search often return results that are semantically similar but not the most directly relevant. Re-ranking defines this initial list by performing a deeper semantic analysis, ensuring that the most important information rises to the top. This enables better RAG performance. In retrieval augmented generation pipelines, re-ranking is essential to provide the most relevant context to an LLM. The LLM needs the best possible information to generate accurate responses and avoid hallucinations.
So here we received reports from the LLM in the novelty assessment part and the SNT guideline part. Now what will we do is take these reports and concatenate them, and we will carefully craft a prompt for the LLM to perform evaluation of our proposal. So how we will do this is we will use chain of thought reasoning, and we will ask the LLM to first of all evaluate our proposal based on multiple aspects instead of just giving one arbitrary score. And these aspects include budget analysis, technical feasibility, scalability, industry relevance. So we will ask the LLM to give a reason for each of these evaluation scores on various aspects, and this is called chain of thought reasoning, where the LLM will be explaining the weaknesses, strengths of the proposal on various aspects. And based on this, we will get a final evaluation score report along with the explanation for each of these scores. Uh, so this was the evaluation part. And now, in order to evaluate our RAG pipeline and how good it is performing, we first of all created a synthetic dataset of 100 proposals in order to simulate how real proposals would look like when we'll be working with real data. And we had various attributes for each of the proposals like abstract, institute, research, budget, and various budgets. So we stored all of this in a vector database. And then what we did was, using this dataset, we created another synthetic dataset for evaluation of our RAG pipeline. So this dataset consisted of question, answer, context, and ground truth. So initially, the answer and context part of this data was empty, and we used a RAG pipeline to store the retrieved context for each question. In this part, these were the contexts which were retrieved from the vector database, and the answer was the output given by the LLM. And once we did this, the dataset looked something like this. uh, and this had 45 entries. This data set of evaluation for evaluation of our RAG pipeline had 45 entries. And based on this dataset, we evaluated our RAG pipeline on two aspects. One was context precision. Context precision tells us that the retrieved context from our RAG pipeline, how relevant it is to the query which we use to retrieve these contexts. And another metric which we evaluated our RAG pipeline on was faithfulness score. And faithfulness score tells us that the response generated by the LLM, how consistent it is with the retrieved context. So based on this, the score is from 0 to 1 on both of these metrics. And now OS will explain the scores which we got for both of these metrics and the rest of the evaluation part.
Continuing on our ragas pipeline, so as Saj just explained about the scores we just used, which was the faithfulness score and the context relevance score. So we use ragas, and which is an evaluation framework to measure system performance by testing answer relevance and faithfulness to documents. This helped us calculate the both the scores. So we were able to achieve the faithfulness score of 0.9244 and the context relevance score of 0.9677. Now these scores range between 0 and 1, 1 being the one giving the best result and zero being the lowest. Moving, so this was the pipeline which we use, wherein we use the JSON, which is the filled JSON of question and answer fields, and the context fields, which we send to the LLM along with our evaluation metrics, which is these two. And this is how we obtain for all these questions and answers we obtain. Uh, for each of the questions, at last we obtain this this CSV, which contains our user input, the retrieve context, the response, and our faithfulness and the context relevant scores. Now, this was about the evaluation part. Now, speaking about how our approach is novel, so we deploy two such novel functionalities in all of the approach. Number one is re-ranking, and number two is the chain of thought processing. So Ariba has explained all about re-ranking, what we do in the re-ranking. So what has been done? We retrieve the top K proposals or the top K guidelines. We re-rank. We re-rank it. Why do we re-rank it? Because sometimes the proposal which has been ranked low might be more similar to the one which has been ranked high. So in order for that scenario to not occur, because the top one which has a very less similar score might get infused in the context, while the bottom one, which is very contextual heavy, which is very similar, because of the ranking, initial ranking, might not get involved in the context. So that's why we are re-ranking it, the so that there's one check which ranks it, and there's another check which re-ranks it, so that we're able to get the best context, which we infuse it with our original proposal and then send it to the LLM to generate a report. The another thing which we are using is the chain of thought analysis. Now, what is the chain of thought analysis? So after all of this pipeline stuff happening and the general report, and we get this report, we get this evaluation score. Now, the chain of thought tells the LLM to not just give a single score, but instead give the reasoning behind it. Uh, why is it important? Since we just don't want a simple score telling me about what the proposal is. Where does it rank? Let's say in budget. Where does it rank in terms of novelty, or where does it rank in terms of following guidelines? We just don't want a single what do you say, a single score. We What we need is a well defined answer. Why is it choosing that particular score? So for that, we deploy the chain of thought reasoning. So give a score and then justify, give a valid reason, which the evaluators might see, so that they're able to find out if whether they want to use the proposal or not. That's why we are using this novelty of chain of thought reasoning. Now, talking about why did we not we also tried a very other alternatives, which did not give us the desired results. One such thing was knowledge graphs. Now, knowledge graph based approach is suitable for mostly unstructured it's suitable for structured text, which is very entity relationship heavy. Now, proposals involve mostly unstructured data, which is not very entity rich, and graph relationships add no real analytical benefit in the proposal aspect, in the aspect of proposals. So, this knowledge graph approach increased complexity without improving any kind of performance. Another approach which we utilized was a hybrid knowledge graph plus RAG approach. Now, this required heavy ontology design and maintenance, and two systems to manage, and it was very less efficient, giving us not very desirable approach, not very desirable results, but being the but carrying a lot of dilemma. Now, so we at last we stuck with a simple RAG pipeline in order to achieve the required results, and as you can see, we did achieve significantly good results. So that's all from my side.